Welcome to a project Flight Fare Prediction. In this project, we'll be predicting the correct flight fare for any journey using different machine learning approach and then automated machine learning approach. What is the motivation behind this project? We have often heard travelers saying flight tickets are often very unpredictable and very hard to guess. You also have observed by yourself that it is very difficult to predict the prices of a flight ticket. They can vary from day to day, from class to class, and it's become very difficult to predict whether what a price will be for a flight. Now, it is also often observed that if one might see a price today and checks the same flight price tomorrow, it's a whole different story. It has become a very big problem, and if we can do something to ease it, it will be such a relief. What we can do about it is we can create a machine learning model which will help us in predicting the prices of a flight on inputting some of the attributes. These attributes can include then what is the name of the airline and what is the class of the journey and what is the time of the journey, different source, destination, and many other attributes. We'll be using a data set in which various airlines prices between the months of March and June of 29 are provided between various cities. We'll be using this data set to feed our machine learning model and then eventually to our automated machine learning model. Let me tell you what AutoML is. AutoML enables developers with limited machine learning expertise to train high quality models specific to their business needs, which means that if you don't have much knowledge about machine learning, you can use automated machine learning to do all the machine learning work which a data scientist do, which comes like testing different models, hyper tuning them, checking their accuracy, and selecting the best model. This all work is done with the help of AutoML. There are numerous amount of automated machine learning libraries available, but we'll be using AutoScaler in this project. Let's have an brief introduction about AutoScaler. AutoScaler frees a machine learning user from algorithm selection and hyperparameter tuning. It leverages recent advantages in Bayesian optimization, meta learning, and ensemble construction. You all have heard about the scikit-learn library, or the sklearn library. This is basically the automated part of this. As you can see in the figure, we'll be providing a data set. AutoScaler will do all the model building and hyperparameter tuning work for us, and we'll be able to predict the results. Now, there are two types. The one is the classification AutoScaler and second is the AutoScaler regression. Classification, as suggested from the word, it is used when we are solving a classification problem like the churn prediction or predicting whether a customer is a fraud or not. Here, the problem which we are having is a regression problem, so we'll be using AutoScaler regression. I'll be telling you in the further tutorial how to use it. Now, what will be the timeline of our project? We'll be first doing the data analysis part in order to analyze our data, understand the data, if how our data is related. Then we'll be shifting to the feature engineering part. In this, we'll be doing different operations like one-hot encoding, label encoding, standardization, and all the different data pre-processing techniques. We'll be also selecting the best features. Moving on, we'll be doing model building using the machine learning algorithms. I'll be showing you which machine learning algorithm I'll be using and how we will hyper tune it. Then eventually in the last, we'll be shifting to automated machine learning in which we'll be using the AutoScaler library to do all the work which we have done above in a few lines of code. So at the end of this project, you'll be able to learn all these things and implement on your own. So let's begin. Hello all. So now let's begin with our project. Our project name is Flight Fare Prediction using machine learning and AutoScaler. As I've already given you the introduction about the project, this is the context which I've taken from the literature. I have already told you why this project is important and what is the motivation behind it. I have told you what is the timeline of our project, that is the data analysis, feature engineering, feature selection, model building using machine learning, model building using AutoScaler. So now let's start with our project by importing the different libraries and our dataset. Now let's import the different libraries which will be helpful in feature extraction, data analysis, and different procedures. We have imported pandas as PD, numpy as np, matplotlib for visualization, and Seaborn also for visualization. Now, as we are working in a Google Colab environment, there is a different procedure to import our data. What you have to do is first you have to mount your Google Drive into this environment. How you can do that is you can just simply click in this icon. It will do. It will mount your drive. You have to execute this. You'll execute this, and what it'll do, I have already mounted my drive, so it's showing the device drive already mounted. If you have not mounted the drive, what you can do is it will give you a link. You have to click there, you have to authorize your account, and you just have to copy paste the link which will be provided to you in the next window, and then your drive will be shown something like here. As you can see, drive, and these are all the different things which are present in my drive is shown here. Now, if I want to read a data, what I'll do is I'll be importing that file into my Google Drive, and then I'll be finding it here. And let's say I have to read my flight data. So this is my CSV file. I'll be copying the path. I'll be pasting it here, and I'll be executing df.pd.read CSV. I'll be executing it, and then I'll be seeing the same. Now, as you can see, this is my train data. I have the price information. Now, I also have my test data. So I'll be reading the same by doing the same method. I'll be copying the path of my test data. The only thing you have to do is you have to import your file into a Google Drive, which is necessary for doing further processes. Now, what you can see that this is a test data which has no price info. For the sake of simplicity, I'll be combining both of the data set. What you can do is you can do all the things in your test data, in your train data, and then predict using your test data. But what I'll be doing is I'll be combining my both train and test data for the purpose of feature engineering, so that I don't have to do the feature engineering process for both the data separately. So I'll be, for the sake of simplicity, I have created a data frame total df, and I have combined both the data set into my total df part. Now, as you can see, if I'll write total df.tail, it will show me the all the data set which is present at the end, which is my test data set. As you can see, the price is nan here because it don't have any price. And as I'll see total df.head, it will show me the all the data which is present in the present, which means the train data. You can see that there is the price column because this is my train data. When I see to the total shape, as you can see, this is a quite large data set which has around 13,354 rows and 11 columns. Now, understanding our data. So these are the different size of the training data, and this is the size of test data. We have combined both our data. That's why it is showing 13,000. Otherwise, the training data is 10,683 and test data is 2,671. Now, these are the different features our dataset has. Airline is the name of the airline: Indigo, Air India, Jet Airways. Then the date of journey is the date of the journey which the passenger has to do. The source is from where the passenger starts his journey, same as the destination from where the passenger will end his journey. The route is the main route that taken by the flight. It means that the different if it's a direct flight, there'll be no route in between, and if it's a halting flight, then there'll be different routes. And the next one is our the departure time, arrival time, duration of the flight, the total stops. As I said, that if there is a halt, then it will be showing the different stops. Then additional info, that this is the additional information by the flight, that if there is something special, there is something economy class or business class. These are the information. Then the next is the last is the price. This is a dependent variable which we have to predict. So this was a brief info introduction of our data. In the next section, we'll be doing the data analysis part. Hello. So now let's begin with our data analysis part. In this section, we'll be observing our data, that how our data is related with the price. We'll be seeing the different features, different attributes, and how they are related with the price. So now let's start with the airline. We'll be seeing that how many different airlines are there and which is in abundant. Now, as you can see, There are different airlines like Jet Airways, Indigo, Air India, multiple carriers, SpiceJet, etc. What I did is I simply use the command df airline dot value counts. What value counts will do is it will give me the sum of the different passengers which are present in my different airlines. These are the total. This is my train data. This, if you'll sum it, it will be around 10,000 because this is my train data. I have taken my train data. I have selected, as you'll remember, I have stored my train data in df variable. In order for the sake of data analysis, I am using only my train data. Now I can see that what is the relation between my airline and my price. What I'll be doing, I'll using a cat plot which is present inside the C1 library. It will be displaying me different box plots, collective box plots with all the different airlines. So from this data we can see that Jet Airways Business is the costliest of all. It has the highest quartile range and the average is also the highest, around 55,000. And for the rest of the airlines, the average is quite similar. Like for the Jet Airways, multiple carriers and Air in India, it is almost the same. And then we can see that for the Spice Jet is the least costly of all. These are all the box plots. I hope you are all familiar with what box plot is. It will be showing me the outliers and the 75th percent quartile and the median and the average values. Now I'll what I can do next is I can see what how the price is distributed from the source of the destination. First I'll see what are the different sources in this data. So these are like the Delhi, Kolkata, Bangalore, Bombay, Chennai. We can see how the price depends on the source city, and I'll be using the same cat plot. As you can see, the average price is not much varied. Although in the Bangalore side, the higher quartile range is quite high, around 60,000, right? And say, comparing with the other cities like Kolkata, Bombay, and Chennai, they are quite less. Bangalore and Delhi have quite high quartile range, which means that they have quite some of the flights are of higher range in from Bangalore and Delhi. Now, if we do the same for the destination part, what we'll be seeing that there are different cities of destination, and if we see the plot, okay, it's also similar for the same. In this New Delhi, Cochin and Bangalore almost have the same plot, which means that they almost have the same prices. Only difference is the New Delhi as the have the highest quartile range, which these are the outliers. You see the different things. So which means that there are some exception. There are some of the flights which can be seen in the additional info column, which are quite high. If we exclude these, then it is almost the same. And being the Kolkata and Delhi with the least of the price if they are the destination. Now these are the different durations. So it shows us the 110,683. Why is this? Because it is obvious that every flight will have a different duration. So if there are 10,683 records, there will be 10,683 durations. If I want to see each of the duration, what I can do is I'll simply erase the sum command and then it will show me what are the different duration. But I'm not interested in that because it doesn't give me any significance. I just used it to find out that isn't there any null values or not. Although we can do it from using the simple command is null, but I only used it for experimental purposes. So now this was the data analysis part. There is not much in compare. What you can do is you can also see how the price is depending on the different total number of stops. Like when you'll see the data. Now, if you'll see, you can also see what is the price dependency on the total number of stops or the additional info which is given. If there is some extra privileges given in a flight, the price will be high. You can do this as the your additional assignment and include it in your project. So this was the data analysis part. In the next section, which is the most important one, we'll be doing the feature engineering part. In that part, we'll be and converting different categorical variables into numeric and doing the label encoding part, which is the most important part before the model building. So this concludes our data analysis section, and then we'll be doing data feature engineering and feature selection part in the next section. Hello, welcome to our feature engineering section. In this section, we'll be converting our data into a certain form so that our model can understand it. This is a very important section after the model building. In this section, we'll be converting different types of alphabetical data or continuous variable into a certain numeric value so that a model can interpret it better. So first, let's have a look at the data again. As you can see, this is our data. These are all in different formats. These are all are basically object types. We have to convert this in, we'll be converting this into some categorical variables based on the attribute. So first, after when seeing the date of journey, as you can see, date of journey present in the format 24/03/2019. What we'll do, we'll be taking out the date, month and year separately. You can also do this by the command which is present in the Python, that is dt command, dt.date dt.month. It will also give you the same, but what I'll do, I am splitting it here on the basis of this slash column. So when I use this command, it has split this the whole date on the basis of this slash, and I am returning out my first string, then second string, then third string. Now if I'll see my data, as you can see, I have three new columns: date, month and year. Now I'll drop this date of journey column. Now, if I see my data types, as you can see, these three columns are of the object data type. What I want is, I want them to be the integer, as they are the integer. So I'll convert their data type into integer. Now if I'll see, as you can see, the data type is converted to int64. Let's have a look at our data. Now the date of the journey is dropped and I have the three new columns. Now what happens is this, there is one column additional info. We don't know much information about it. So we'll see how important this is and what is the impact of it in the price, so that we'll decide if we have to keep it or we should drop it. So these are the different additional info present, and these are the number of passengers which are opted them. Now we'll see what is their impact on the price. As you can see, the business class is only having the largest impact because for obvious reasons, and the no info and the other things are quite same. But if we drop this, we'll lose some information, so we'll keep the additional info and we'll convert it into some categorical variables in the next section. Now arrival time. If you see the arrival time, it is present the time, and thus in some of the rows there is some date, so we don't want it. We'll separate it, the time and the date, and we'll only keep the time. So what we'll do, I'll split it on the basis of that space, and I'll take the first string. So after this, as you can see, the arrival time, only my time is there now, because I don't want the date, because this is a column of time. Now there is a column named total stops. Now total stops, as you can see, let's see how many total stops are there. Okay, see, one stop there are 7,056 flights, non-stop are 4,343 flights, and second stop, third stop and fourth stop. Now what I'll do, I'll fill all the null values. I'll if there is any null values, I'll fill it with one stop, and then I'll see that if there are any null values present. As you can see, there are no null values present in the total stops. Now what happens is, these are all in the numeric value, but there is one variable, one attribute, that is non-stop. I have to convert this into a numeric value. What I'll write a code in which total def I'll replace the non-stop with zero stop. Now when I'll see it, now as you can see, the non-stop is replaced with the zero stop. And now what I'll do is, I don't want this stop, I only want the numeric value. So I'll split it with this basis of this space, and I'll return only the first string, that is the numeric value. And although I'll store it in a different column named stop. Now when I'll see it, As you can see, this is a different column, stop and total stop. I don't need total steps right now, so I'll drop it. As you can see that I have dropped total stop, and I have new column named stop, in which 0, 1, 2 are described. They are describing how many stops the flight is taken. Now the same thing will convert the data type, as the data type which is assigned to it before is the object data type. We'll convert it into int. Now, as you can see, this is the int data type. Now similarly we'll do the different. We'll convert all the different variables. This was the first part of the feature engineering. We'll proceed. We'll convert to different variables in the next part. Hello all. Welcome to a second video of our feature engineering part. In this video, we'll be continuing with where we left off previously. Now, as you can see, in the arrival time, we'll be starting with the arrival time. We'll separate the arrival time with the hours and the minutes. We'll create a new column, which is the arrival hour and the arrival minute. We'll separate it with these two dots, and I will retrieve the first in the arrival hour and the second in the arrival minute, and we'll just convert it into a int type, and we'll drop the arrival time column. Okay, now when we'll see our data, as you can see, this is the new column arrival hour, and this is the new column arrival minute. We have dropped the arrival time. Now we'll do the same for the departure time. As you see, we don't want it to be together. We want the different hours and we want the different minutes, so that it is better for the model. Now there's a column called route. In this, it is showing us that what is the route taken by the flight. If it is a non-stop flight, there will be two routes, and if it has flights, if it has stop, this means that this has two stops, CCU starting point, then IXR BBI, then the destination is BLR. So these are the route taken. Now what we'll do, we'll separate each route, and we'll store it in a different column. We'll split it with this arrow and the space, and we'll store it in route 1, route 2, route 3. Now what happens is, if we'll see, so the different route will have some none values, right? This has only two routes. So what will happen to the route 3, route 4 and route 5? They'll have the null values. So what we'll replace that null values with none. Now when we'll see a data, now as you can see, the route are mapped with these route 1, route 2 values. And if we take the example of first data, the first source is BLR, then the route 2 is Delhi, DEL. There are no other routes, so it has assigned me none. Same for the second. The first is CCU, second is IXR, third is BBI, fourth is BLR, and the fifth one is none. Similarly, it has mapped for all my data. Now I'll simply drop the route column and the duration column also, because each flight is having different duration. It serves me no purpose and no value, so that I'll drop the both of the columns. Then I'll see. Now let's see how good my data looks, right? I have filtered all my data. Now I'll see if there is any null values in my data or not. So basically there are no null values in my data. The only thing it is showing is my price value. This is actually not the null values. These are my test data. In test data, as you remember, there was no price column. What I am doing is I am taking my test data also into my train data. What you can do is you can separate your test data and your train data, uh, but in this case I'll be taking both of them. Now what I'll do, I will fill my price column with the mean of the price, which is present in the train data. Now when I'll see, there are no null values, it is 0. And if I'll have a look at my data, this is my data where I have everything, the price and all the columns. Now what I'll do, I'll use a label encoder. What a encoder is, it will map the labels. Like for the airline, it will map a certain value for this airline and for the routes. Now this is one method, But for the categorical variables, what we can do is we can use one hot encoding. We can perform one hot encoding. One hot encoding is a method in which various dummies are created. For example, if I'll perform the one hot encoding in the airline section, so there are different airlines. So the it will create that number of columns similar to the total number of airlines, and it will assign the value. For example, in my first column, if there is indigo, it will assign one for indigo, and the rest will be zero. This is a very good method of feature engineering, and this is performed to obtain a higher accuracy. I have not done it here. You can simply do it on yourself. I hope you know it, or if you don't, you can simply Google it, and you'll find out how you can do one hot encoding. You just have to use the get dummies command, and it will automatically perform. But there is one disadvantage of one hot encoding, because suppose if you have a very large number of categories, if in the airlines there are around 15 to 10 10 to 15 airlines, what will do, it will create 10 to 15 number of columns, which will create many number of dimensions, which can lead to a curse of dimensionality and eventually our overfitting of the data. So but in this case we can perform one hot encoding, as our variables in any of the attributes is not much higher than 5. You can easily perform one hot encoding as your assignment. Now performing the label encoder, I have imported label encoder from sklearn.preprocessing. I'll be doing the label encoder in these things, in the categorical variables and the route, the airline, source, destination, additional info, route, and the different routes. I'll be doing fit and transform in the same line. And now when I'll see my data, now see how beautifully our data has done. All the variable airline, source, destination, routes are converted into some category, into some labels, as I said in the previous section. Now the same I have written, you can also perform the one hot encoding. Now there is one another column which is the year. This is same for all, because as you remember, I told you that the data is only for the same year. So there is no use to keep this column. We'll drop the year column. Now our data is ready. Now the final thing what we have to do before model building is we'll select the features. There are different features. We'll select the feature which is the most important. That I'll show you in the next section. Hello all, welcome to a feature selection section. In this section, we will see what all the features we can use and which feature is the most important, so that we'll use only those features for developing our model. Now the first thing we'll do is we'll we will separate our data into independent and dependent variables. Now what I have done, I have created two X and Y columns in the two data frame. Basically in the X data frame, I have dropped the price column from the total DF. That is basically my independent variables, and in the Y I have only taken the price column, that is which is basically my dependent variable. I'll train this on the basis of with these variables. Now when I'll see, this is my X column, okay, and this is my Y. Now what I'll do is I'll import one thing which is lasso and select from model. Select from model is a criteria, is a method for feature selection. In this I'll give a parameter. I will give a parameter, on the basis of that it will select the model. The parameter which I have taken is the lasso. Okay, now if you'll just see what lasso is. In statistics and machine learning, lasso is a regression analysis method that can perform both variable selection and regularization. What is do, it will perform an analysis and tell me and find out that which model has the best importance. The first, before training the data, we'll split our data into the train and test data. Next. Now let us fit our model. What I'll be doing, select from model, I'll be passing out the lasso command. I'll be selecting alpha value is 0.005. It is always better that if you select the alpha value, a low alpha value is generally better. What is saying select from model is not defined. Okay, sorry, I have not executed it. Now See the it is fitted. Now we'll fit this model with a train data, X train and Y train. Now as you can see, it has given me all the parameters which it have taken. Now I'll use a command get support. Get support. What it will do, it will tell me, give me a array of the features it has selected. It is given true, and the feature it is not selected, it will be giving false. But in this case, it has selected all the features. So I'll be getting the column names. See, it has selected all the features. Now, what we can do if you want to view it visually, we'll import one model which is known as extra tree regression. What it will do, will fit the data in this, and what we'll do now, see it has fitted the data. We'll create a GG plot. In this, we'll create a plot which is known as feature importance. In this, what this extra tree regressor will do, it will provide us with the different features and their importance, and we can plot it in the form of a GG plot. Now as you can see, this is the importance and this is the features. As you can see, root 3, date, stop time, these are all the importance feature which is estimated by extra tree classifier model. So this is was our feature selection part. This in this I showed you how you can select your features on the basis of different parameters, and this you can do it in different data sets and try out and find out different things. Now in the next section, we'll be building our model using the machine learning technique. Hello all, welcome to our next section. In this section, we'll finally build a model using the machine learning algorithm, and the algorithm we'll be using in this case is the random forest regressor. In case if you don't know about random forest is basically an ensemble technique. It is a collection of various decision trees, and it is of two types: the random forest classifier and the random forest regressor. So this is a regression problem. We'll be using the random forest regressor. We'll import it from the sklearn.ensemble library, and we'll just fit the model. Now as you can see, these are the different parameters it has taken the basic parameters, the default parameters which are present. We'll be hyper tuning it in the above also. Now when we fit our data, we'll directly predict it with the X test. Now we'll see the score. As you can see, this is our training score and this is our test score. Now what we can do is we can plot a distribution plot. In this, we'll be saying how we'll be doing y test minus y predict. What it will do, it will create a distribution plot of the values of the distribution. As you can see, the zero is in the abundance. If the zero is in the abundance, it means that the difference of our predicted value and the actual value is zero, which is a quite good thing, and this is normally distributed, and zero is in the abundance, which we can also create the same as a scatter plot of the different y test and y pred values. As you can see, this is our y test and y pred values, and these are the sum of the values which are like the outliers and which are not correctly predicted. We can also create we can also see what are the different scores. This is our ME score, MSE square, RMSE square. This is our metric score, R2 score. Generally our RT square of 0.75 is considered a good score, and this is our score. Now this was our model in the normal primitive algorithm, my random forest model. We can hyper tune it. How we can do it? We'll hyper tune our model with the help of randomized search CV. Now there are two types two hyper tune it. There is one thing called grid search CV, and the another one is randomized search CV. In grid search CV, what happens is it searches the data in a particular label, like there'll be a certain folds. If I use the grid search CV, it will take take that data and then not repeat the same process with that data. But in randomized search CV, what happens is it takes the data in folds, so my data will get again and again trained, which is quite a good thing. So I'll be using randomized search CV here, and what I'll do, I'll tell all the parameters. These are the simple parameters which are taken, which are used in the random forest. You can have a documentation look of random forest, and you will understand what this is. What I did is I used the n estimator part. In this I created a different value integer values from 0 to 1500. I've taken number of and the n estimators, how estimators are. Okay, then the next is the max features, the same for the max depth. These are the different sample slips and sample sleeve. These are the values which I want to give in my randomized search CV model, so that it will carry out these variables and tell me that what is the best model. Now see, I have done randomized search CV, then estimator is reg rf, obviously the random forest model. The param distribution is this, the scoring which I've stored in this, and iterator is the 50 and CV is 5. These are the different other variables for randomized search CV. Now I'll fit it. Okay, now it will fit for the different folds. Now what happens, it will take a certain time because it will be fitting many number of parameters. What I did is I have already fitted it. It will take around 10 to 12 minutes to check out all the different parameters, and from that what I got is I got my best parameters at the n estimator is 700, minimum sample split is 3, and split is 3, and minimum sample leaf is 1, max feature is squared, and max depth is 15. These were the best parameters which I obtained. What I'll do is I'll just stop it. Okay, I'll stop it. And it will take around 10 to 12 minutes to give you the best parameter. You can use the command rf random dot best parameters to see what were the best parameters, and you can simply fit your model with this. Now I'll fit this model and predict it. See, this got fitted with the same parameters which I have given. Now I'll create the same distribution and scatter plot. The distribution plot I have created. See, this is my distribution plot. Okay, most of the values is my in the zero section. Most of the values in my zero section. This means that my model is performed well. This is my scatter plot. Okay, this is my scatter plot, and these are my scores. These are my score. This is my ME score, MSC score, RMSC score. Now this was the part of our model building using the random forest. That's the machine learning technique. Now what we have to do in the next section, we'll be using the automated machine learning to see how we can do all of this with the help of AutoScaler. I'll be discussing what auto machine learning is and what AutoScaler library is in the next section. Welcome to our last section of this project, which is model building using automated machine learning. So as I have discussed in the introduction video, what automated machine learning is, it will automate all the machine learning, model building and hypertuning part for us. We'll be using AutoScaler. There are different libraries such as Tpod, AutoScaler, AutoKera, SpyCaret, but I'll be demonstrating you this project with the help of AutoScaler. Now, AutoScaler frees a machine learning user from algorithm selection and hyperparameter tuning. So previously in the previous sections, we saw that we used the sklearn library. In that we use the random forest model. Now what in this it will do, it will run over all the different models it have in the sklearn library and give us the best model with the hyperparameters for our project. So now, in order to install your AutoScaler, you have to use these three commands. Make sure you use these three commands in order. First, you have to install SwigY, then the Python NumPy, then the AutoScaler. Then only you will be able to run this in your Colab environment. It will take around 1 to 2 minutes to get run. I have already installed it, so that's why it is saying requirement already satisfied. Now you just have to import AutoScaler, then you will import AutoScaler as regression as rig. Now AutoScaler has two types, right? One is the classification and one is the regression. Classification is for classification part, regression is for regression part. It will import all the libraries, all the models it have for the regression as reg. This is the demonstration of how we have to load our data, but we'll be using the extrain data. Remember, AutoScaler only automates the machine learning model building part, the pre-processing part you have to do. If you will pass the raw data in your model, it will cause your model to fail because it will contain many numerical data, unstructured data, and the object type data, which will cause the model to fail. The pre-processing part you only have to do. So I'm using the same data which I pre-processed for my previous section, that is the random forest section. As you can see, this is my extrain data, and this is I am defining my model. Now I am defining my model like auto ML, the reg which I imported, and auto ML regressor, time left for this task. Now what is this? This is basically saying me that it will take around 120 seconds to fit my model. Now I have used this as a time constraint. You can remove that and run your model. It will run for around 5 to 10 minutes. If I'll be using 180 seconds, then it will run for around 180 seconds, then it will fit my model according to that. You can use it, you can see how much time it takes until fit your model more properly, and it will give you a higher accuracy. Now it will fit your model, it will take around 120 seconds. I have already fitted it. Now what we can do, we can print a letterboard. Now as you can see, these are this is 9 is the model ID, which means that more than 9 models were taken into account and tested, and we have the top 3 according to the cost function. As you can see, our main aim of our model building is to reduce the cost function, right? So the model which is having the least cost function is having the first rank, which is the gradient boosting, and ensemble weight is 0.56, then the random forest, then the gradient boosting with ensemble weight 0.30. These are the duration which it took. I can also describe my models, right? I can also describe my models. As you can see, it is describing, it is showing my top 3 models and what are the things which were used, encoding choice and the categorical transformation and all the different things. Okay, all the different things which are used. See, this is my pipeline. It is basically showing my pipeline which is used, the regressor pipeline which is used in all the different models. Now what we'll do, predict, I'll predict my data with the X test data. See, this is my I have predicted my model. These are my results. Now I'll simply use the same distribution plot again and the scatter plot which I used to see the accuracy above. See, this is my distribution plot, and most of the values lie in my zero region, which means that my model is correct. Model is predicted most of the values right. Because why zero? Because I am seeing a distribution plot about y test minus y prediction. So the values, more the less the difference, more is my corrected value. This is my scatter plot of my y prediction and y test. As you can see, this is a great straight line, and this is a cluster, which means that my model is quite good and quite correctly predicted. Now these are my metrics which I've imported. These are the different mean square error, root mean square errors. These are my different accuracy. Now this is how this is a small demonstration how you can use AutoScaling for your model. I have used you can experimented with it. You can remove the time barrier and you can see how good the model performs and what is the accuracy. This was a simple demonstration. All the notebooks and files and data will be provided to you. You can experiment it. You can see how you can create different models, or with the same data you can create a better model with more accuracy by experimenting more, by exploring in the AutoScaling library. You have type in Google AutoScaling.regression. It will give you the documentation, see different parameters and experiment it with it. This was all about this project. Thank you.